I wanted to, a few comments. Overall, I'd like you to enjoy this weekend. This is an opportunity to meet and network with the Casis management. For entrepreneurs, this is an opportunity to step forward and build our 21st century new space economy. This weekend, we'll meet many of the new space industry leaders and view the on-ramp to space commercialization. In the United States, we excel at spaceflight and entrepreneurship, and new space combines both of these worlds. Silicon Valley is the mecca for technology and business innovation in many industries, and new space should be one of them. After this weekend, I hope you'll be excited about the investment potential in the space in the 21st century, as I am as Managing Director of the Silicon Valley Space Center. And with that, we have a slight change in schedule because I don't see that Richard David is here, but I would like to welcome Colonel Gregory Johnson, and I have a brief bio on Colonel Johnson, who's an outstanding individual and certainly a hero for our country. In 1980, Colonel Gregory Johnson graduated from Park Hills High School in Fairborn, Ohio. He received his Bachelor of Science in Aeronautical Engineering from the U.S. Air Force Academy in 1984, and his Master's of Science in Flight Structures and Engineering from Columbia University in 1985. In that sense, our Colonel Johnson and I share a common alumni affiliation. In 2005, Colonel Johnson received his MBA from University of Texas. Following graduation from the U.S. Air Force Academy, Colonel Johnson was designated as an Air Force pilot in May 1986 at the Reese Air Force Base in Texas. He was retrained as a T-38A pilot instructor at Reese until 1989, and Johnson was selected as an F-15 Eagle pilot for the 335th Fighter Squadron at Seymour Johnson Air Force Base in North Carolina. In December 1990, Colonel Johnson was deployed to Saudi Arabia, flying 34 combat missions in support of Operation Desert Storm. In December 1992, he was again deployed to Saudi Arabia for 3 months, flying an additional 27 combat missions in support of Operation Southern Watch. In 1993, he completed his Air Force test pilot school at Edwards Air Force Base in California and graduated in 1994. He was assigned to the 445th Flight Test Squadron at Edwards Air Force Base, where he flew and tested F-15s, FN-15Bs, and T-38s. Selected by NASA in 1998, Colonel Johnson reported for training in August. After 2 years of initial astronaut training, Colonel Johnson was assigned to the Shuttle Cockpit Avionics Upgrade Council, redesigning cockpit designs for future shuttle missions. Colonel Johnson served as the Chief of Shuttle Abort Planning and Ascent Procedure Development, and he was a key player in several Tiger teams, including the external tank foam impact test investigation and impact test team investigating the cause of the Columbia accident in 2003. His team proved that the external tank foam debris on ascent could critically damage the shuttle leading edge thermal protection system. Colonel Johnson was a pilot of ST-123, the Endeavour mission from March 11th to March 26th in 2008. The 25th Shuttle Station Assembly mission. Endeavour's crew delivered the Japanese Experiment Logistics Module pressurized station, the first pressurized component of JAXA's Kibo laboratory, and the final element of the station's mobile servicing system. The mission was accomplished in 250 orbits of the Earth, traveling more than 6 million miles in 15 days, 18 hours, and 10 minutes. Colonel Johnson was a pilot on STS-134 Endeavour, the International Space Station, on May 6th through June 1st of 2011, which was the penultimate mission of NASA's shuttle program. The mission marked the final flight of the shuttle Endeavour, During the 16-day mission, Endeavour delivered the alpha magnetic spectrometer and spare parts, including 2 S-band communication antennas, high-pressure gas tank, and additional spare parts for the denture robot. The STS-34 mission included 4 spacewalks and was completed in 15 days, 17 hours, and 38 minutes. So I especially like the part about the particle accelerator, because that's actually provided phenomenal results on, for anybody that's been following dark matter, on the abundance of positrons. So from October 2011 to November 2012, Colonel Johnson was appointed a 1-year detail as Associate Director of External Programs, Center Operations at NASA Glenn in Cleveland, Ohio. There he managed all public affairs and outreach and education programs for NASA Glenn after returning to Johnson in 2012. Colonel Johnson headed the Visiting Vehicles Working Group within the Astronauts Office, which helped plan, train, and execute missions for SpaceX, Dragon, Orbital, Cygnus, JAXA, HTV cargo missions, and from the to and from the International Space Station. Most recently, Colonel Johnson departed NASA and accepted a position as Executive Director of Casis. Please join me in welcoming Colonel Gregory Johnson.
Well, Sean, first thing I'm going to do is talk to I'm going to toss this out at Patrick. I'm just joking, but you got a really long bio, and I appreciate it. Thank you very much. I'm very happy to have a lot of those experiences, but now I can only talk for 2 minutes. I'm sorry. For starters, I'd like to thank the guys from Casis that are here today. I was given credit from the mayor for putting this thing together. That wasn't my work. That was Justin's work. And Justin is one of our business development guys. And Patrick also helped. He's our marketing communications guy. And Dwayne Ratliff, where are you, Dwayne? You're somewhere. Oh, there you go. He's COO, and he's really been the brains behind this organization for the last 2 years. So with me, I'm the new guy, but I'm the happy guy to be part of this team. But anyway, I joined Casis just 2 months ago, and as you know, I did work with NASA for 15 years, got the chance to fly a couple shuttle flights. But you know, the 2 years that I've been here with Casis, or 2 months, I mean, I've been here with Casis, what I've seen is a team that had a lot of struggles early on, and now they are full of passion, they're full of intellect, they've got some inroads in communication, and they are ready to execute commercial research and utilization of the space station. So with that, I'm really excited to be part of this team, and it was a great next mission for me. I heard because of the sequestration, or I guess the furlough, you were going to have an astronaut speaker later in the presentation today. So I couldn't help but give you a couple of videos. I tell you a little bit about, you know, the bridge from what I used to do to what we're doing now. You know, our nation has partnered with 15 other nations and expended a huge amount of time, money, and effort to build the International Space Station. We dedicated 36 shuttle flights over the last 12 years to put this space station together. $100 billion has been spent on our planet to build the International Space Station. It is a precious resource. It is the only zero gravity laboratory in our known universe. And so our job is to employ this wonderful laboratory and put it to work. Now NASA, that's the Thunderbird dive. It's pretty. We worked most of the time, but some of the time we took time out for a little fun. I did spend 32 days on orbit, and probably 2 or 3 of them were kind of fun days. Well, they were all fun days, but some were more fun than others. But this is assembly complete, and there's an Endeavour attached to the space station. And you know, NASA uses space station to expand the footprint off our planet, you know, to further human space exploration. And although we get a scientific benefit from the space station through spin-offs and by dedicated science and technological research on the space station, it doesn't do enough to address the commercial aspect of space. And so even when the space station was being assembled, our stakeholders, particularly Congress, decided we need to have an ISS national lab, a national lab that gives back to the people. And so that's why Casis was formed. And so now we're in a new era of space research where we're appointed by Congress to manage the national lab. 50% of the U.S. Up mass, down mass, and crew time and volume on the space station is controlled by Casis. And so we're in a unique position to bring the space station to you for low cost, which can ultimately translate to return on investment. And we're not these super scientists, as I guess you know from my bio. I've written one paper in my life. I have no patents. But there are people in the Casis team that are super smart and they have PhDs. But most of those smart people are people like you, the ones that come up with the ideas. We're facilitators, and our job is to take your ideas and take hardware and put it up on the space station to create opportunities. And so that's what it's all about. And it's about creating opportunities here on Earth, not for the purpose of going to the moon or to Mars or to the near asteroid, but to create value on planet Earth. Well, so that's a daunting task. And how do we know it's going to work? Well, it already has in space. We have dedicated science. We have lots of examples where we have learned things that have benefited the Earth. And look around you, look in your pockets. You've got cell phones. We drove here with GPSs. Luckily, I had a GPS. I could walk from the hotel to here because there's a lot of buildings around here, and I thought I was going to be late. But the bottom line is, we take these things for granted. We talk on the cell phone, and we're actually going all the way up to the geo satellites and back down. 1/2 second delay with our cell phones, and people don't often think that it's because of our research and work in space that has benefited us here on Earth. And so, of course, there's lots of different examples and many, many others where we've improved our planet. I'm going to go through about 4 real quick examples of how we've commercially exploited our research in space. We can build big crystals. We can build huge crystals, and then we can better understand and test drugs that have a stronger impact on those crystals. I was in Europe a couple of years ago, and I was holding a turbine blade from an Airbus engine, and the turbine blade was half the weight of the conventional turbine blade. And I was told that this turbine blade, and it was experimental, was created because the crystals, the material in the turbine blade, the crystals grew bigger in space. The materials scientists better understood the material and were able to build this turbine blade for half the weight. I mean, you can imagine the commercial impact if you could put turbine blades that weigh half of conventional ones. Your thrust-to-weight ratio and everything in the compromise of an airplane would be significantly enhanced. It's also this case in biology. We've created drugs. In space, we've learned that living organisms, their bones atrophy, osteoporosis is evident early on in zero gravity. Your brain figures out you don't need bones. And so astronauts have been studied to combat that osteoporosis. And we've done a lot of research, and there's a lot of promising research, by the way, with gene expression in rodents in our very near future. But this drug, Prolia, commercialized over $1 billion of sales last year. Other success stories include microencapsulation, where you're using mechanisms to deliver drugs to patients. And these are very promising, and we're going to be treating cancer, diabetes, and other ailments on the Earth. LiQUIDMETAL Technologies is a company that was created around a product that was actually produced in space. And as you can see, they've been a very successful company. Also spin-offs. Now, here's the interesting thing is when NASA puts investments, or other space agencies put investments in space, and we get these spin-offs, very smart innovators use some of the technologies and they grow companies around those technologies, or they apply those technologies to future possibilities, and we get spin-offs. Depending on which statistician you communicate with, perhaps $1, every dollar invested in the space program since the Mercury days has translated to $7 of economic value. That's an intangible, that's a hard thing to prove. But what I do know is we're the richest country in the world. And we have the best space program. Now that's kind of a weak correlation, but I think our success in space is one of those ingredients that's enabled us to be the leading technological nation. But as I said, Casis, our job, is not going to be spin-off. It's not going to be the indirect benefit. It's going to be the direct benefit, because your ideas will go to space and they will create economic value. They will create scientific or technological breakthroughs, but they're all going to be focused at coming back to the Earth. So, Casis is about setting new expectations. You might think it's expensive to get to space, or you might think that how would you get there? Or, hey, we're going to fiscally cut off funding. I'm going to be left holding the bag. That's what some NIH researchers have experienced in the past. We are not a government entity, and we are not constrained by the same rules that the government is constrained by. So we can get you to space not in 5 years, but in, well, hopefully 5 months, but I can't make that claim. How about 1 to 2 years? And the transportation's paid for, and the volume's paid for, and the astronaut time is paid for. It might cost you some skin, but basically the cost of paying the researchers, creating those ideas, maybe some implementation costs, but super, super cheap right now. I mean, this is an emerging market. This is the early stages of opportunity, and it's, frankly, a great deal for innovators to get science in space. So we'll take your idea. Now, there's 3 areas that we hope to exploit on the space station in our one half of the National Lab. That's microgravity. That's taking advantage of the unique vantage point of being 250 miles above the Earth's surface and covering about 90% of our Earth's planet in series of orbits. And then also the extreme conditions. There's capability to experience experiments outside the space station, and those, of course, can impact lots of different technologies, including artwork. By the way, we've learned a lot about restoring artwork because of what we've learned from atomic oxygen interactions up in space. And of course, on the right, you can see a lot of examples of, organizations, entities that have, or even projects that have benefited from space research. Now, at Casis, over the last 2 years, we put together a pipeline, and this pipeline starts with a proposal initiation, either from our solicited proposals. We put out 4 RFPs. Actually, our latest RFP just came out earlier this week. Or unsolicited proposals, because we think, we've got a lot of smart people attached to Casis, and we think we know what's going to be fruitful in space. But honestly, there are ideas that we didn't even think about. So we'll accept both proposals that are solicited and unsolicited, and we'll analyze them all through the same process. We initially have an operational checkout, and then we go through a pretty thorough scientific and economic evaluation to eventually put the best projects onto the space station. Here's some of the projects that we've got in the pipeline. Now, we have about 40 projects. A lot of folks think, hey, Casis, what are you guys doing? Well, we actually got our first sponsored payloads up to orbit just within the last couple of weeks, and of course, our first real payload was software that occurred on the space station about a week prior to that. But this is looking at the microgravity side of the house, and we have PCG, protein crystal growth experiments. We've got fluid physics, we've got dissimilar materials, and all the great names, the Mercks, the Procters and Gambles. We have a really cool coding experiment from Puma Cobra Golf that we're putting up, I think in ARC 1, I believe, ARC-2, I'm told by Patrick. But you'll learn a little bit about the ARCs in a second. But lots of projects in our pipeline that we expect some great results from. The extreme conditions are also being exploited. We've got some computer on module testing up there, and of course we're doing nano testing and solar array testing. And also we just put out an RFP for remote sensing, so there are companies that are trying to take advantage and entities, for example, the Naval Research Lab, entities trying to take advantage of the wonderful positioning of the space station with manning 24/7. I mean, there are astronauts and cosmonauts right now living and working on the International Space Station, and they can help us run the equipment or the cameras or you name it for remote sensing. So the bottom line is Casis takes all these individuals and tries to level the playing field and make it equal access for commercial enterprises, institutions, OGAs, even individuals. You know, the starving geniuses out there. We do have a little bit of money that we can fund some of those starving geniuses. But we also have a partnership group that can match money, foundations that want to sponsor activities and bring money or their brands into space. And of course, we also, if a company brings a great idea and money, they have the opportunity to go into space. And of course, we weigh them, they go through our process, and eventually get onto the space station. And right now, our allocation is not full. I mean, it will be. So right now is the opportunity to get into space. As I was saying, it's an emerging commercial market. If you think about transportation systems, maybe not back to Fred Flintstone's Flintstonemobile, but maybe back to like the stagecoach, and then trains, and then automobiles, and then airplanes. You know, in the 30s, only the very rich could fly airplanes. It was an anomaly to even get to see an airplane. And now, 100 years, not even 100 years later, just a normal person can fly from coast to coast. I flew from Florida last night, a 6-hour flight from Orlando straight to San Francisco, And so what's going to happen is space is going to be that next new frontier, and it's emerging. I mean, we are just starting, but yet there are a lot of outside entities that have skin in the game. Bigelow, they've got the Genesis inflatable modules, and they've been up there for years. We're probably going to attach one of those to the space station. Virgin Galactic, you've seen them in the news lately, and they're going to be flying, they're exploiting the space tourism market. SpaceX and Orbital, of course, there are ways to get stuff to and from the space station. They've got a lot of skin in the game, and they've got a lot of work to do. I think we have about 17 vehicles this next 12 months that are going to go to and from the space station. Here in the Silicon Valley, Google sees the opportunity to invest $1 billion per mission to mine asteroids. And so here we are, Casis, for just the super duper cheap prices that we can offer you, comparative to some of the skin in the game from these other entities. And it's real, it's now, it's available. And there's more. There's PR and marketing. One of my complaints with NASA is that we had difficulty PR and marketing. But we have some very smart minds, such as Patrick here in the room, that have partnered with the right people to bring pop to the marketing of space. ARC is advancing research knowledge. That's what it is. Okay. Advancing research knowledge, and we've built a brand around our groupings of space projects. We have ARC-1 and ARC-2 and so on, and we have this wonderful patch that's been advertised through electronic media and created tens of thousands of impressions. We also created this brand, Space is in it. It's kind of like, it's a value-added brand, kind of like made in the USA. So there's so many different opportunities to commercialize our products in space. But frankly, it's not about branding or just about branding. It's about the whole value. It's about making it affordable, making it accessible, bringing the right partners together to exploit this wonderful space station that we have, and to benefit mankind. It's an exciting mission to be. I flew a couple space shuttle flights, and this mission is much more exciting than another one-off space flight, because that's probably what I gave up, one possible other shuttle flight to get to impact and work with these really smart people to benefit humanity. So this is the time, and this is the opportunity that we have before you. And later this few days, we're going to be talking about a lot of the details. This is kind of a broad brush review of what Casis is all about. So anyway, thanks for your time, and I guess we have time for, do we have time for a couple questions? Any questions out there? Yes, all the way in the back.
What is the intellectual property process and the methodology associated with the program?
That's a very good question, and that's something that we're working through. We have a cooperative agreement, and the cooperative agreement kind of establishes the very unusual relationship between the government, NASA and Congress and Casis and our partners. And originally, intellectual property was a kind of a stumbling block for some of our potential commercial customers, but we've softened the language, and without getting into specifics, I think it's comforting to some of our new big commercial partners. So in that regard, that's about as deep as I think I can get into it. Is Dwayne here, or is he gone now? Because Dwayne knows the exact details, but I wouldn't want to venture it. Suffice to say, it's been an issue, and we've been working it. So we're gonna make it work for you. Justin, you have something to say?
I can actually speak to that a little bit, because I helped with some of the briefings that we did on the Hill this past summer. And traditionally, NASA has retained language for use of their facilities to be able to claim intellectual property for government or so-called national security issues. However, they recognize that it is a stumbling block to commercial utilization of the station. So NASA Legis Affairs has worked with Congress in the next authorization act to add language to the National Lab authorization that will actually ensure that commercial users retain their own IP. And NASA Legal has given us their word that any users of the National Lab that sign on before that law goes into effect will be grandfathered in, and NASA will not try to take ownership of our users.
A great question. Anyone else? Yes, ma'am.
So one of my observations was that a lot of the possible customers would be interested in getting their samples back with high frequency. Are you looking into trying to set up customized on-demand sample return system from the ISS?
Well, one of the approaches, and we're partnering with NASA on collecting data, is to collect more data that is more generalized than going into the one-off, one specific experiment, one specific piece of hardware, and having one grouping of data coming back down. We're also working at gathering data and getting the data down here without having to fly something back. So that's one of the issues we're working with. So does that answer your question? It's very important because of the limited resource. I expect that right now we've mined some projects in Boston, and we're working some things in Houston. This is our first kind of interaction in the Silicon Valley. We're going to have a lot of projects out there, and there's going to be a management of those projects necessary, and the sharing of information between different entities is going to become increasingly important. Yes.
So the ISS as a U.S. national laboratory, do you deal with outside of U.S. experimenters at all? I say this because I was recently in communication with some folks who were organizing a meeting in Europe, and they're saying, oh, they're bemoaning all the costs in the traditional extremely long process that they have to go through to do anything, and put something up in the station, or that sort of thing.
That's a great question. Let me not get myself in trouble after 2 months on the job. Casis is new. We're gaining credibility. We were formed to benefit the U.S. taxpayer, and we're getting appropriated funds to do that project. But we're challenged to use that small stream of support and grow it into something much bigger. So we'll be able to do things that NASA can't do and commercialize the space station. So as we make ground and we get credibility and our taxpayers realize the benefit from Casis, and should we graduate to help our neighbors around the world, that would be a reasonable progression. However, I think at this very moment, it's probably a little bit premature for us to, open up an office, Casis Europe. But that being said, I like what you're thinking. I really like what you're thinking.
Can you sort of be a spark towards Europe opening its own analogous?
Well, I think that we certainly want to be a model example of what the facilitators might look like. Yes. And so I think as we grow through this process, because we're new, we're learning as we go. This has never been done before. But I think we've made some great inroads in the first 2 years, and I know we've gotten some calls from our European neighbors, but I'm not certain that now is the exact time that we go into that realm. Okay, yes, sir.
Could the questioners identify themselves?
I certainly will. Richard Gardner, CEO of Zero Gravity Solutions. What will Casis's role be in the upcoming debate on Capitol Hill about ISS life extension through 2028?
So I view our role as like right in the middle of the fight. Had a meeting a couple weeks ago with John Shannon and his team. Of course, they're the Boeing guys who manage the ISS, the operation of the ISS. And they and we and many people probably in this room and around the country and around the world have a vested interest to extend the space station. And as people like you, if you give us a trophy, give us a, maybe not cure of cancer, but give us a significant product, a significant innovation that we can brag about. Science, economic value. Make some money in space, because this is a precious resource. And like you said, if we don't use it, I mean, it's a short-term thing if we don't use it, right? This is 2013, we're talking 7 years. But I fully expect that we're going to extend it to 2028, and I think that already we've got, projects on the boards that are going to be that are going to prove to be fruitful, and we'll be able to make that argument. But I view Casis as right in the middle of that. I think our success is ultimately Boeing's success and the station's success. A couple more questions, and I think we're out of time. Yes, sir?
Al Gomez, San Jose State. What's your budget, and how much does any of it come from anywhere but the government?
We get a $15 million revenue stream from NASA. 80% of it is to basically build our organization and keep the lights on, pay salaries and travel and whatnot. And we have a small grant budget of $3 million per year. However, just in the last couple of years, we've built partnerships, and so already I see our grant potential roughly doubling. And just like any other nonprofit, when you first start up, a lot of your expenses come from just building the infrastructure. But we're hoping that the ratio is going to be much better than 50-50, and even maybe 30% infrastructure and 70% granting once we can build those partnerships that we're frankly trying to do right here in the Silicon Valley. By the way, I was going to harass my guys. None of my guys have ties on. I'm the only one with a tie on. So I'm a little bit upset with them. I should have known you come to Silicon Valley, it's more casual here. I don't have to be stodgy and wear a tie. Come on. Okay, anyway.
But it is California, and the Midwest sucks.
Yes. Okay, final question.
So to tie back to my earlier.
I guess I
question-
didn't answer your question. Are you
No,
going to put me
but-
on the spot?
No,
Are you going to shoot me down on my very last?
No, actually, I wanted to maybe look at it from a different perspective, given the question about extending lifetime of ISS beyond 2020. So what I was thinking is there value in looking what are unique things that we can manufacture on orbit and return them to Earth? So not only data, but products that can be manufactured uniquely in microgravity on orbit. And that requires an on-demand customized return from orbit. And if we identify such applications and such a system, then the fact that ISS needs to be there becomes obvious.
I see where you're getting. And you're right, there are some ideas that I've heard about. I think fiber optics is one of them, where we have the capability to manufacture products in zero gravity that you just can't manufacture here on Earth. I think there's some nanotechnology as well. When you take gravity out of the equation, it's amazing the sorts of things that you can do. Many of you are the scientific researchers and the innovators out there, or the investors, but when you take gravity out of the equation, many physical processes change, and they sometimes become simpler. You can learn about the roots in a plant much by taking gravity out of the equation, because there's no gravity, and roots are partly programmed, plants are partly programmed by the existence of gravity. Spiders, you should see the webs that spiders make when you put them in zero gravity initially. Ignition, the way that a match looks when you light it. Ignition in space looks more like a dandelion head. And so there are so many possibilities. I mean, the only limit to these possibilities is our minds. So this is a great emerging market. It's a great opportunity for everybody in the country to take part in the research on the International Space Station. And I see Sean is standing here. I'm out of time, but we're going to have 3 days of wonderful discussion, and so I look forward to those. Thank you.